are you doing the warm-up over there?
No.
Change that. Real quick, before we get going on the warm-up, I did mention yesterday about us being really close to the end of the semester, and if you look at the calendar over here on the wall, sorry, I wasn't pointing at your head, but like the calendar behind her, basically the end of the year can fit onto my calendar. So it's literally 5 weeks, and we have one virtual day in there. And the way it ends is that we have finals for first through third hour, and then fourth hour on the last day, and then like kind of like a locker clean out and supply hand in and stuff like that. But it's gonna go super fast. So again, I mentioned they'll probably have about 2 more tests. So if you're not happy at where you're at in this class, you have to do something about it. Like that's gonna whip through, and just know that that's gonna go super fast. And end of the year is busy, and the weather gets nicer, and so we feel like doing less schoolwork, so use your time wisely. So make sure that you guys are aware of where you're at in this class, and then if you want to change something, you have to do it soon. So it's kind of crazy how once I put it that way and like looked at that calendar, we're close to the end. So stop in for AR if you guys need to. You're welcome to come in and work on corrections, turn in missing work, whatever. If you guys need help, come in and use that AR time. So for simplifying our fractions, so hopefully the 6 over 18 was a little bit easier maybe than this one, but we'll talk about it. What does 6 over 18 become, or what did you do to it? What did you do in this problem? Headphones out, please. Thanks. What did you guys do? How could you change that? Nate, what did you get for yours? What's that? 1/3. So someone else tell me how he got there. How did he get there? Yeah.
6 times 3 is 18.
Yeah, so you realize that 6 goes into 18, so 6 times 3 is 18. That means I can divide these each by 6 and simplify them. Sorry. And 6 divided by 6 is 1. 18 divided by 6 is 3. So we get 1/3 as a fraction. That's an equivalent fraction. It means the same thing. We prefer that answer over the 6 over 18. Now, number 2, I want to point something out with you guys with this one that hopefully you guys noticed or realized once you kind of work through it, is there's some simplifying we can do, but we could probably multiply. So what most of you guys did, you tried multiplying top and bottom. So 6 times 2 is 12. 3 times 4 is 12. What happens when we have a fraction with the same number on the top and the bottom? It just becomes 1. So they kind of cancel each other out, but they cancel to be 1. And the reason for that is kind of this again, is I can divide them both by 12. So a lot of times people cross them out, but they don't equal 0, they equal 1. They simplify, just be 1 over 1, or just the value of 1. So we're going to use that today, but we're adding the variables to that, which makes it obviously a little bit tougher. We're going to review a little bit of what we talked about yesterday. And each day we're going to add a little bit more. So that's why if you struggle a little, I want you guys to ask so you're not confused. We're like on day 4 of this and you're like, I didn't understand day 1. reviewing yesterday a little bit. So the product of powers is what we talked about yesterday. And that's multiplication. So this is the rule we learned yesterday. What did we do with those exponents? Remind me of yesterday. What did we do there? What did we do with the exponents? What was a to the third times a squared? What's that going to be? You guys know this? What is it? Holly, what did you get? We do a to the third times a squared. What do you get? This was from yesterday. Yep, you just add those exponents, so it's a to the fifth. Yikes, this board is having a rough morning. Sorry. So add the exponents. So now quotient of powers means division. So now I'm dividing. Yikes. So when we divide them, what do you think we should do with the exponents this time? What do you think? Yeah, we were adding here, so we're going to subtract there. So now we're going to subtract the exponents. So a to the third over a squared, I'm just going to do 3 minus 2, and that's just going to be 1. But I'm going to kind of show you guys why that is as well. So kind of like yesterday I talked about, remember I said, well, there's 3 a's here and 2 there, so that's a total of 5. This is 3 a's, and this is 2. So I want them to cancel, kind of like I did in the warm-up question. Anytime I have an a over an a, they cancel. So those 2 a's are going to cancel. I'm just going to be left with a to the first on top. So there's an a to the first, is 3 minus 2 is 1, so that's just our a to the first. So we're going to subtract those coefficients. Over here, if you guys recall, remember we still multiplied the coefficients. So if there was coefficients, we'd have to multiply those. That was our rule yesterday. We don't have any coefficients in that problem, but lost an I in there somewhere. Now what we're going to do with division is like we multiply the coefficients here, we're going to divide or simplify the coefficients. Yikes. I'm sorry, you guys. I want to restart my computer and see if that helps or something. I don't know. It's really being bad today. Okay, so we'll talk about how to do that here. And work through a few problems, and then we're going to kind of put the 2 ideas together. So these first couple of examples here, so our examples 1 and 2, I want to simplify these. And this is division. So I have to use my rules up here. I'm going to subtract the exponents, and then I'm going to divide or simplify the coefficients. Now when I subtract these, I do want to think about them in terms of, like, where are there more in the fraction? So we're going to talk about that a little bit as we're talking here. So I have m to the 4th over m. Do you guys remember what m's exponent would be there then? 1. A 1, thank you. So I need to subtract those coefficients. So I'm going to do 4 minus 1. Now if you ever forget this rule, you can think of it as there's 4 m's on the bottom, or 4 m's on the top, sorry, and 1 m on the bottom. So that means there's going to be 3 left on top. So an m to the 3rd, 4 minus 1 is 3. Now those coefficients are the 12 and the 3. So we either want to divide or simplify those. So we're going to think about that as 12 over 3 we want to divide or simplify. What's 12 over 3 going to be? What's 12 over 3, you guys? 4. And if I wanted to write it as a fraction, it'd be like 4 over 1, or you can just write 4. So if you want to write it as a fraction, that's fine. Otherwise, we can just write this as 4m to the 3rd. That should be a 3. All right? Now this next one's a little bit more complicated. Now I have x squared and I have x to the 7th. I'm going to subtract those, but if I do 2 minus 7, I get a negative number, and that's really confusing with fractions and exponents. So I'm going to tell you to think about this a little bit. So if there's 2 x's on top, or x to the 2nd on top, and x to the 7th on the bottom, where will there end up being more x's? Think about that. So there's x on top, and there should be 7 on the bottom. 7, right? Yeah, there's 7. So if there's 2 on top and 7 on the bottom, 2 of these are going to cancel with 2 of those. So the x's are going to end up on the bottom of the fraction, if that makes sense. How many of them are going to end up on the bottom? 5, because 2 cancels with 2. So what we're going to write then, on the bottom of the fraction, we're going to write x to the 5th. So you have to think about where they're more of the variable and where they're going to end up. Now you don't have to write this all the way out. This is just like what I'm visualizing and trying to get you guys to see. You don't have to write this out, so don't feel like you have to write a bunch of whole x's or y's or whatever it happens to be. If there's like 7 of them down there, you don't have to do that typically. I'm just doing it to help you to visualize what's going on. How about 4 over 6? Simplifying that like our warm-up, what can those both be divided by? 4 and 6 by 2, yep. So 4 divided by 2 is 2, 6 divided by 2 is 3. So this ends up being my fraction. It's really important to show that the x to the 5th is in the bottom of the fraction and not on the top. Okay? Any questions on those? We'll do a couple more together, and then we're going to do a little bit of practice. All right, so let's look at these together. So I have k to the 7th over k to the 5th. Where are there going to be more k's? On the top. There's 7 on top and 5 on the bottom, so like knowing where the bigger number is, like you guys got that figured out. But since this is division, we're going to subtract those. So we're going to do 7 minus 5, but we know that the 2 k's are going to end up on the top. That makes sense because there's more of them on top. So I'm going to write k squared on top. Now if you like to visualize it and write it out all those times, you can. You don't need to though. But then I'm going to look at these m's here. more m's? On the bottom this time. So there's only 3 m's on top, but 10 on the bottom. So how many are going to end up on the bottom then? 7. Because we just do 10 minus 3. So we're just subtracting. It's just, I have to think a little bit about where I should subtract from and where they should end up. Okay, here's the stumper. What happens to that p to the 5th? What's that? Go away. Kind of like the warm-up. They cancel each other. They're the same. All of them would cancel. We're going to talk tomorrow about what 5 minus 5 in that case really means. I know that's going to be 0, and it's kind of a precursor to what we're going to talk about tomorrow. So the p's are gone. They all cancel. So we're just left with this. All right, let's do one more, and then we'll do some practice. All right, so remember that when there's not an exponent, we assume there's a 1 there. Sorry, a 1. So I have x to the 1st over x to the 5th. So where's the x going to end up? The bottom, very good. How many of them? 4. So there's 1 on top and 5 on the bottom. So x to the 4th on the bottom. And just like the p's in the last one, the y's are going to cancel, right? So can I just leave the fraction like this? Or does anyone know what we need to do with it? What do you think? Yeah, just kind of a placeholder, so there's something kind of like the warm-up question number 1, where we didn't leave it as just like 3 on the bottom of the fraction. We're going to put a 1 there, kind of just a placeholder. Okay? So it's a 1 over x to the 4th, because that's where the x's end up. All right, I need to get this online for our virtual students, this first part. So why don't you guys grab whiteboards?